Okay, this is the P2 paper from June 2024. It's question number 10, and this is a question that's going to be using some modelling with series for this first part here, and then the second part, completely different question, is going to be exponentials and logarithms. So let's read it through. It says the number of dormice and the number of voles on an island are being monitored. We're just going to talk about dormice to start off with. It starts with there being 2,000 of those on the island, and then a model predicts that will increase by 3% each year. The number of dormice at the end forms a geometric sequence, and it says, can we find a number of dormice after 6 years? So, and answer to 3 significant figures. Yeah, so let's just be really careful with this. I'm going to do this quite slowly. We've got that A is going to be equal to 2,000. It says that there's 2,000 at the start. And what I'm going to be doing each time is if there's a 3% increase, then I'm going to be multiplying by 1.03 to indicate that. Now, I'm going to do this quite slowly and just say, right, so at the start, there are 2,000, and then I'm going to say, right, at the end of year 1, there will be 2,000 multiplied by 1.03. At the end of year 2, there would be that number multiplied by 1.03 again. So in other words, multiplied by 1.03 squared. And then the question that they want is how many are there at the end of year 6. So at the end of year 6, then following that idea through, it's 2,000 times 1.03 to the power of 6. If you're not careful, you might get that value wrong where you're not concentrating on the wording of the question. If we do that and we work it out and we do it to 3 significant figures, then it works out to be 2390, and that's that first part done. For the second part then, when it starts talking about the number of voles, it's now saying we've got this as being our model formula is going to be that. We are told that 4 years after monitoring, there was 3,690. 7 years after monitoring, there were 3,470. So if I put both of those pieces of information in, I should be able to get rid of all the variables and end up with a solution. So B, we're using the formula n equals AB to the t, and then the information they told me was that 3,690 will be when t equals 4, and they told me 3,470 will be when b is equal to 7. So you should have seen these questions before. If you haven't, this might be quite difficult for you to do or for you to work out what this first stage is. But when we see this in previous questions, if I divide those two, the a's will cancel, the b's will cancel just to leave me b to the 3, and obviously I'll get a value there. So you need to have seen that technique once before, then you remember it and you say, okay, yeah, no, this is going to work out really nicely now. ab to the 7 over ab to the 4 is equal to 3470 over 3690, and then the a's cancel, the b's come to b cubed equals, and b cubed works out to be equal to 0.94, which means that b then is a cube root of that, which is 0.9797, and so on. They asked for it to 2 significant figures, I think, 0.98. So if that's true, I can now put that back into either of these 2 equations. I'm simply going to choose the top one, doesn't really matter, but I'm going to say 3690 is equal to AB to the 4, so 3690 is equal to 0.9797 to the power 4. Use the exact value, don't use the corrected value there. If I do that, then A works out to be equal to 4,000, and so my n equals AB to the t now works out to be n equals 4,000, 0.98 to the t. So when we're going back there, it says, can we find the equation of this giving a and b both the two significant figures, and I've done that for that answer. So part C, it says when t is equal to capital T here, the number of dormice is equal to the number of voles. So what I'll do is I've got, for part C, I've got an expression 1.03 to the t, which is for the original one, which was the dormice, and then I've got equals to what I've just found, which is 4,000, and then 0.98 to the t, and that's for the other ones, and they're equal to each other. So if they're true, then I can work out what t is going to be from this. Just going to take a little bit of work. 2,000 divided by 4,000, then take the 4,000 over, is going to be equal to 0.98 to the t divided by 1.03 to the t. So in other words, 0.5 is going to equal 2, and then we can call that 0.98 over 1.03 to the t, can't we? So if we're doing that, then easiest thing is to log both sides now to get rid of the power in a second. Log 0.5 is equal to log 0.98 over 1.03 to the t. Why am I doing that? Because my next step using log rules is I can take that t down, can't I? So that's the whole point of doing that, is so for the next step, we get log 0.5 is equal to t log 0.98 over 1.03, and so we can work out what t is. T is one of those divided by the other one. Let's just write it out. We don't particularly need this step, but that divided by the other one over 1.03, and then what does that work out to be? That works out to be 13.9, and in the question it said giving your answer to 1 decimal place. So I've just made sure I've gone through and done that. Okay, yeah, not too bad for a last question on a P2 paper. Hopefully that all makes sense to everybody.